Hi everybody, this video is going to talk about combining like terms and distributing. You can follow along in your notes packets. Alright, so let's start with some vocabulary. So, a coefficient is the number in front of a variable. Now, the first variable we have in this expression is a negative x. Well, a negative x really does have a number in front of it, even though you can't see it. Anytime there's not a number written, it means that there is a 1 there. So if we have a negative, and that's all in front of x, that really means that we have a negative 1x plus 3y squared. So the coefficients here for x would be negative 1, and for y would be 3. Those would be the coefficients, the numbers in front of the variable. Now, like terms are terms, and when I say term, I mean each thing in the expression. So if we go back to our first example, negative 1x is one term, and 3y squared is another term. So that expression has terms total. So for like terms, they're terms that have the same variable and the same exponents. And the reason that this is important is because we're going to be combining a lot of terms this year, and we have to make sure we know what can and cannot be combined. So if you look at this bigger expression down here, we have 1, 2, 3, 4, 5 terms. Now, I can combine some of these terms together if they have the same variable and the same exponent. So here's what I like to do. I like to mark them each so that I know what I can combine and what I can't combine. So the first thing I notice is I have a plus 2 and a minus 4. Okay, those are like terms because they're both just constants. Another pair of like terms would be this positive 5x and this minus 3x. Now the reason that I can't combine the 5x and negative 3x with the negative x squared is because the negative x squared has a different exponent. Yes, it has the same variable x, but it doesn't have the same exponent, which is the second rule. So if I wanted to combine these like terms, it would look like this. Negative x squared didn't have anything to combine with, so it just stays negative x squared. We drop it down. 5x minus 3x, well, if I have 5x's and take 3 of them away, I would be left with 2x's. So positive 2 plus 2x. And lastly, negative 4 plus 2 would leave us with minus 2. So you can see how I took an expression that had 5 terms, and I combined some terms so that I have an expression with only 3 terms. So we're going to see some more examples of that. Now, I just walked through the steps, but it might be helpful to have some steps written down so that you can look back at it and remember how to do it. So to combine like terms, your first step is to find the like terms. Okay, that's when you want to underline, circle, square, star. You want to do something to establish the groups of terms. All right, your second step is going to be to add or subtract the coefficients of the like terms. So if we go back to our example, that would be like when I took 5x minus 3x. I took 5 minus 3 and made it a 2x. The third step is to make sure that you don't have any more like terms. So after you've combined, is there anything left that can be combined further? Sometimes there is, sometimes there isn't. It really just depends on how many terms you have, and maybe you missed something the first time you went through it. Your last step, okay, it's really just a reminder. It's super important that you remember that in order to combine like terms, it has to be the same variable, and they have to have the same exponent. So let's see some examples here. Example A, we have only 2 terms, 5x and 2x, and these terms are like terms because they both have the variable x and they both have the same exponent. Each of these x's, even though it's not written, each of these x's really has an exponent of 1. So we can combine these. 5 plus 2 is 7. So if I take 5x plus 2x, I get 7x. For b, again, just two terms. They're both like terms because we have z to the second power. So if I have 3z squared minus 4z squared, 3 minus 4 is negative 1. So we have negative 1z squared, which is just the same as negative z squared. I want you to go ahead and pause the video and try examples C and D. All right, for example C, we have 4 terms this time. I noticed that we have a positive 2m, a positive 5m. Those are like terms. We also have a 4m squared minus, I'm going to write it in here, minus 1m squared. So let's start with the terms that have the bigger exponents. So 4m squared minus 1m squared would leave me with 3m squared. 2m plus 5m would give me plus 7m. Okay, and I go back and check, can I combine anything further? The answer is no, because even though they both have the variable m, we have two different exponents. We have m squared and just m, which is raised to the first power. All right, example D. I have some constants, 5 and negative 2. I have some y's, and I have a y squared all by itself. Okay. So let's again start with the one with the biggest exponent, the y squared. There's nothing else for 2y squared to combine with, so we just copy it down. There's nothing that changes. Let's move on to the y's. So negative 4y plus 6y will give us a plus 2y. And finally, our constants, we have 5 minus 2, which gives us a positive 3, so we'll put plus 3. There's nothing else that combines, so this is our final answer. And remember, we're not solving anything here. The key word is simplifying. We're trying to make it less messy. We're trying to make it easier to work with, nicer to look at, by combining some like terms. I want you to pause and try examples E and F. Now, example E has something that looks trickier than it really is. Before I go to combine like terms, I want to take care of this right here. Okay, you probably remember that if I'm subtracting a negative number, that's the same as adding that number. So instead of writing it as minus negative 4, what we can do is we can change this so that it's just a plus 4y. So I'm going to rewrite the whole thing so it's not so messy. We really have 4 plus 6y plus 2z plus 4y minus 8. Okay, and now I'm going to go through and find my like terms that I can combine. So we have some constants, 4 and negative 8, that can combine. We have some y's that can combine. And we have e all by itself. Now, when you have multiple variables, I'm not going to be too picky about the order. Let's go ahead and just copy the 2z down, since there's nothing for it to combine with. Let's go to the y's next. 6y plus 4y would give us 10y. And our constants, 4 minus 8 would give us negative 4. We go back through, there's nothing left to combine, so this is our simplified expression. Now, f is a little tricky. I look at f and there doesn't seem to be anything I can combine because there aren't any like terms. I have an a and an a squared, but I can't combine those because the exponents are different. I have a b and I have a c cubed. So if you look, we don't have any like terms. There's nothing that can be combined here. So our final answer is what we started off with. Okay, and you can just make a note here that there are no like terms. Nothing combines. Now, we're going to talk about something new here. We just talked about combining like terms. What I want to talk about is something called the distributive property. And what it says is, so basically what we're doing is we're taking the A that's on the outside and we're multiplying it to things inside. So whenever you do this, I want you to draw arrows. I want you to draw arrows from the term that's outside, which in this case was A, and I want you to multiply it to each thing inside of the parentheses. So let's try it. For example A, we have a 5 outside and an x plus 2 inside. So we're going to draw our arrows first from 5 to x and 5 to 2. And we're going to multiply, okay? And we multiply every single time that we distribute. So 5 times x just gives us 5x. 5 times plus 2, or positive 2, gives us plus 10. And then that's it. Okay, the reason we like to distribute is it gets rid of those parentheses and it makes it easier to work with in an equation and find some like terms. In general, whenever we're working with an equation we're trying to solve, we want to try to distribute to help get rid of those parentheses. For example, B, same thing. We have an 8 outside of the parentheses. We're going to draw our arrows, and we're going to multiply 8 with 2x, and with that plus 4. So our answer here, okay, we're not solving, but our answer, our simplified expression is just 16x plus 32. Go ahead and pause the video and try examples C through F. For example C, we're going to distribute the 4 that's outside to both things inside. 4 times 3x gives us 12x. 4 times negative 7 gives us negative or minus 28. In example D, it's just a little flip-flopped, okay? Our number that's outside is behind the parentheses, so we're just going to draw our arrows this way instead. 6 times 4 gives us 24, plus 6 times 3x, which gives us 18x. So the order's a little different, but it doesn't make it that much harder. For example E, the negative that's just there really means that there's a negative 1 outside of the parentheses. So when we distribute, we're distributing a negative 1. Negative 1 times 8x just gives us negative 8x, and negative 1 times 1 just gives us negative 1, so minus 1. All right, lastly, we have a negative 2 that's being distributed. You have to be careful here because anytime we multiply a negative number with another negative number, it becomes positive. So negative 2 times negative 2y turns this into a positive 4y. Negative 2 times negative 4 makes it a positive 8. Now, let's use distributing and combining like terms within some equations. For example A, what I want you to get in the habit of is any single time that you see parentheses in an equation, I want the first thing you do, I want you to draw those arrows in. Very first thing. Okay, we're going to always start by distributing. So we get a 6x minus 2. And don't forget that this 4 here, that plus 4, needs to drop down. Okay, the 2 doesn't multiply or distribute to that plus 4 because it wasn't inside of the parentheses. Now what we're going to do, what I notice, is that we have some like terms, some terms that can be combined on the left side of our equation. So let's go ahead and do that. We now have 6x plus 2. So you can see every single time we've done a step, it gets a little bit nicer, a little bit cleaner, easier to work with. So now we're solving equations just like we did in the last video. We're trying to get x by itself. We take care of addition, subtraction first. So I need to get rid of that plus 2 by subtracting 2 from each side. Now we have 6x equal to 6. We divide each side by 6. These cancel. And we're left with x is equal to 1. So distributing and combining like terms allows us to work with more challenging and complex equations. It lets us solve them more easily. Okay, and this will be our last example for today. Example B, there's no distributing that we can do, but there are some things that we can combine, some like terms that we can combine together. So let's start on the left side of our equation. And keep in mind, we can't combine things on the left side with things that are on the right side of our equation. On the left side, we have a 5y and a minus y that can combine. We also have a plus 2 that's all by itself. So this left side will turn into 4y plus 2. On the right side of our equation, 6 and 8 are like terms. They can combine together to make 14. So notice I didn't combine the 2 and the 14 together. Okay, they're on separate sides of the equation, so they have to stay separate when we're combining. Now when I go to solve for y, remember we take care of addition, subtraction first. So to get rid of that plus 2 that we have, I'm going to subtract 2. So notice I subtract 2 from both sides. Instead of combining it, okay, which would have been a mistake, with the 14, we actually subtracting 2 from each side. So now we have 4y is equal to 12. We need to divide each side by 4. And our final answer is y equals 3. All right, feel free to rewatch, rewind, pause, and make sure to ask questions. Have a great day.